Welcome to my educational series where you can improve your English proficiency and prepare for exams like TOEFL and IELTS. In this episode, we'll focus on an academic topic. You will hear talk followed by several questions. I recommend that you take some notes while listening because it will help you at the end of the conversation to answer all of the questions in the quiz correctly. So, let's get started.
Ever look up at a mountain and just wonder how something so huge got there?
It really is amazing.
I mean, they seem so permanent, but underneath it all, there's this story of incredible forces at play. So today we're diving into the origins and secrets behind some of the world's most significant mountains.
Yeah, and we've got some really cool research here. We're going to try to boil down to the most fascinating insights without getting too technical, you know?
Exactly. Like no one wants to feel like they're back in geology class. So to start, how do mountains even form in the first place? I keep seeing this idea of tectonic plates, like continents smashing together.
Yeah, that's a big part of it. Think of it like a giant jigsaw puzzle. So the Earth's surface is made up of these massive plates, and when two continental plates collide, it's like an epic slow motion crash. All that pressure forces the land to buckle and fold upwards.
So like the Andes Mountains.
The Andes are a perfect example. That's where the Pacific plate is sliding under the South American plate.
Subduction, right?
Exactly. And that constant grinding is what's pushing up these amazing peaks. But it's also why that whole region is so prone to earthquakes.
Like the planet's reminding us who's boss.
Haha, yeah. And then you have the Himalayas, which formed when India basically rammed into Asia.
Like 50 million years ago.
Right around then, yeah. And yet that collision is still happening today, which is why Everest and the whole range is actually still growing taller.
Whoa. But mountains aren't always formed by continents colliding, right?
Right. There's also volcanic activity. Like, picture a hot spot.
A hot spot.
Yeah, it's basically a plume of intensely hot rock rising up from deep inside the Earth. And as a plate moves over that hot spot, molten rock punches through the surface and boom, you get a volcano.
So that's how we got the Hawaiian Islands.
Exactly. And also Kilimanjaro in Africa, that's another one that formed over a hot spot.
Okay, so let's talk about some of these individual giants, starting with Everest, obviously the world's highest point and still growing thanks to that India-Asia collision we were talking about.
Right, and then there's Aconcagua in the Andes, the highest peak outside of Asia, again, a direct result of that Pacific plate subduction.
And what about Denali? Or is it McKinley?
You can call it either. It's Denali in the native Athabaskan language, and McKinley is the name given by European explorers.
I like Denali better. It just sounds more powerful.
I agree. And powerful is a good word to describe it. The sheer scale of it is incredible, and how it towers over the surrounding landscape is just spectacular.
Now, we already mentioned Kilimanjaro. That's the one with the 3 cones, right?
Yep, 3 volcanic cones, Kibo, Mawenzi, and Shira. Kibo is the highest, and that's the one that makes Kilimanjaro the roof of Africa.
And then there's Mauna Kea in Hawaii. Now, this one is really interesting.
Yeah, Mauna Kea is fascinating.
So its peak is about 13,800 feet above sea level. But if you measure it from its base on the ocean floor, it's actually the tallest mountain on Earth, like over 33,000 feet. It kind of blows your mind.
It really does change your perspective on what tallest actually means. Then you've got Vinson Massif down in Antarctica, a pretty remote giant overlooking the Rhone ice shelf.
Which is a massive floating platform of ice, right?
Yeah, it's connected to the continent, but floats on the water. It just shows you the incredible scale of things down there.
And we can't forget Mont Blanc in the Alps. That one's thanks to Africa slowly pushing its way north, right?
Exactly. And here's a fun fact. The official height of Mont Blanc actually changes slightly from year to year because of the ice cap on its summit.
Oh, wow. And finally, Aoraki in New Zealand, also known as Mount Cook. I love the Maori name, Aoraki, which means cloud piercer.
It's a fitting name for sure. And here's another interesting tidbit. Aoraki was actually even taller before a massive landslide back in 1991, so even these giants are constantly changing.
It's amazing to think that these mountains aren't just static. They're part of a planet that's always in motion.
Exactly. They're a reminder that the Earth is a dynamic, living thing, and that those forces that built them, they're still at work today.
It makes you wonder, what other incredible processes are happening beneath the surface right now, just waiting to be discovered.
Well, that's the beauty of science. There's always something new to explore.
So next time you see a mountain range, don't just see the rock. Think about the epic story behind it. It's a story of tectonic plates colliding, volcanoes erupting, and a planet that's constantly reshaping itself.
It's a story that's still being written.
Thanks for joining us today for this deep dive. Until next time, keep looking up and keep wondering.
And keep exploring.
Thank you for joining me today. I hope you have learned something new and useful, and see you in the next episode. Bye.